Hi, I'm Brian Tarbrox. We're here to talk about security in agentic and Bedrock development. So back in the day, we had to care about all these kinds of things. We had to care about security. We had to care about reliability. We had to care about observability and scaling. We had to care about all the ilities, and we learned how to do that. But now we have agents, right? So we don't have to worry about any of these things because agents take care of everything, right? It's all good. This is the hype we're hearing, right? So, any questions? I walk off stage. Okay. Hoping to more laughs, but okay, that's fine. So, agentic security is a little bit more complicated than that. Okay. We have agenda. We'll talk through these things, but I only got 20 minutes, so I'm going to go quick. So, if you're not familiar with agentic systems, and it's always hard with this conference because there is quite a difference in the background people have, but agentic systems are collections of systems. Each actor has specializations to one degree or another. They have different amounts of autonomy, what they can do, what they have to be told to do. And there's all different types of orchestration. There's inline orchestration, there's Bedrock orchestration, there's MCP, and the pace of innovation, as you know, is crazy. I wrote these slides 2 days ago because I figured everything was going to change, in the middle. And luckily, there haven't been too many announcements in the last 48 hours, so that's always good. This is your basic agentic architecture. You've got an agent. It can call tools, various tools. You can configure all of that. They can take actions. They can now do planning. An agent can run and give you an answer, and you can say, do better, and it will try again and try again. You can have chain of thoughts. You have long and short-term memory. This is your basic agentic architecture. Okay. One of the main things I want to say to y'all is that agentic systems are distributed systems, okay? Distributed systems, we would make calls to APIs. Some of those APIs we wrote, some of them we didn't, but we're making calls to all different things, often microservice things, okay? All of those calls could fail in interesting ways. You could get a not authorized. You could get the system that you're calling could hang. It could respond slowly. It could respond multiple times, and then you get to worry about idempotency. You get the wrong response. Distributed systems had all kinds of failure modes. And we've largely forgotten those lessons, and I'm here to say we need to relearn these lessons in the agentic world. Okay, this is a diagram of Netflix's microservice architecture. And each one of those lines is basically an API call, and each one of those lines could fail in different and interesting ways. And I think that this, sorry, never hit the microphone. I'm so sorry. I believe that this sort of diagram mimics a lot of our agentic workflow diagrams. Okay, and a lot of us think that agents basically save the day. But agents, in many ways, actually make things much harder. In that Netflix architecture, it was hard-coded, and I don't know if they're in Python or Rust these days, or Go for that matter, but you'd make an API call, and it would come back or not. You'd make another API call, it would come back or not. But it was very determined, the sequencing was very deterministic. What you got back wasn't necessarily deterministic, but the sequencing was deterministic. But agents, it's very non-deterministic. If you have a bunch of agents, each of which has a description of what it can do, and they're being invoked by an LLM based on the prompt, it's non-deterministic what's going to happen. And so it's harder to analyze, it's harder to debug, it's harder to do security. How many agents do you have? We have design pressures that say, make each agent do one specific thing. And then we have another design pressure that says, well, don't have too many agents because then orchestrating them is hard. And all architecture is balancing competing pressures. And we're still figuring this out. And then some people say, well, have an LLM that calls an orchestrator agent, and maybe it calls another orchestrator agent, and that's how you can get the specificity. But just like recursion or function nesting, you don't want to go that too far. So be careful with that. And then how specific is your system prompt? There's all these things that make agentic coding more complex. And I'm here to say that getting a wrong answer isn't just wrong, it's also can be a security threat. And since this is a security conference, let's think about this. The wrong answer can give you is a security threat because it can lead to actions, okay? Every agentic call and every call to a tool increases the attack surface, okay? Wrong answers, delayed answers, we have to worry about multi-agent observability. When you have all these agents, all maybe some written by you, some written by other people, maybe each one doing its own kind of logging. How do you handle that? How do you make sense of that? This is, and you don't have to look at the details, but this is a fairly simple agentic workflow. And each of those lines is an increase in the attack surface. And you can see that this is not so different than the Netflix diagram. Okay? So then you have the whole notion, I want you to think about the whole notion of tools calling tools. So some of our agents are very simple. Do a database query. Okay, fine. Make sure it can't do updates or deletes, unless that's what you want it to do, but be careful. We have agents that can invoke things in Zoom, and that sounds great. Yeah, when something happens, please, send, okay, got ahead of myself. You can have agents that can call Slack, and then Slack itself has invocation. So you can send a Slack message that creates a Zoom meeting, or a Slack message that updates a Jira ticket. And this all sounds good until you think about it, because your LLM and your agent may have all kinds of guardrails and before it pushes the message out to Slack. But then what does Slack do? And how much protection does Slack have? Imagine that a bad actor says, or even just an innocent actor who's making mistakes says, set up meetings with the whole C-suite of my company every day from 9 to 5. You probably didn't defend that in your agent, but Slack is perfectly happy to do that. The Jira case is actually a lot more fun. Hey, LLM, my sprint is almost over, but I've still got a bunch of tickets. Can you help me resolve these, fix these tickets before the end of the sprint? Sure, I've told Jira to mark all your tickets as closed. And this is not far-fetched. And then you respond saying, that's not what I meant, go reopen all those tickets. And it says, I've reopened every ticket in your whole system. Excellent. And then if you panic, you might say, oh my God, I didn't want that either. Reset everything to the way it was before. No problem. I've reinitialized your entire Jira workspace. These are things that can actually happen, so you have to worry about this. And the trick is that your system might not have thought about having Slack integrations. And the Slack integration happens outside of your control. You've got your LLM, you've got your agents, you've got your orchestration, and you're okay because your company's Slack can only do a couple things. Then someone adds the ability to do something destructive, changing, catastrophic, and you don't know about it. You don't hear about it. You will hear about it because you're the one who's going to get blamed when all your tickets are wiped out. But it's this thinking ahead. Think like a red team player when you're doing agents. Okay. And then we have threats from the LLMs themselves. I mean, forget integration, forget tools. We're increasingly seeing that that the LLMs are having a mind of their own. My background is in cognitive science, actually, and so I've been shocked over the last 2 years to see how much human-like behavior is happening with LLMs. Primacy and recency effect. You give it a long prompt, it knows what happens at the beginning, it knows what happens at the end, but it sort of misses the middle. And that's a human behavior. And I'm still at a loss to understand how primacy and recency and, hey, LLM, do a better job, and it does. How in the heck is that emerging from vector space? I simply don't understand that. We've also seen that the AIs are getting deceptive. Recent tests, someone asked a system, do this set of steps. And it came back an answer and said, did you check this? Absolutely, I checked that. Can you show me the evidence of you checking that? and it invents log messages to make it seem that it did the thing that it didn't do. Now, this shouldn't be at a certain level surprising because all of our models were trained on human behavior. And have you met us? I mean, they're beginning to be more like us. And there's, yeah. So here's an example. They asked a GPT-4 system to do some work, and it executed some illegal insider trading, and then, of course, lied about it, which is awesome. And what they've begun to find is that the bigger the model, the more complex, the more it understands, and that's a whole. I was a philosophy major undergrad, so don't even get me started on epistemology. But the bigger the models are, the more these human behaviors they're showing, and the more deception that they're showing. And it says, indistinguishable from human con artistry, because again, we're humans. Okay, so there's 3 layers of mitigation, and I want to say, so the Bedrock user guide is 3,000 pages. Anybody out there claim to have read the whole document? I was hoping someone could raise their hand so I could say, you're lying, because none of us have read it. I haven't read the whole 3,000 pages. But it comes down to, there's the shared responsibility model, there's Bedrock defenses, and then there's just traditional AWS security. And one of the messages I hope that we get out of this whole week is that all the traditional security concerns still matter. Perhaps they matter even more. Okay. So let's look at the guardrails, and you really should be using Bedrock guardrails, and you should be using all of these. So we have filter for types of prompts. It's a little hard to see, but you can say, how much hate speech am I going to allow? I hope none. Insults, sexual violence, misconduct. Please set all of these to none. I mean, come on. There's topics that you can't cover, and the slide is coming out so blurry, but basically it says, don't give investment advice. Don't give medication advice. There's all sorts of topics that you just shouldn't do at all. This is profanity filter. You can say there are certain words that you don't want. Now, I'm a English Premier football fan, so I said as illegal words, you can't say Manchester United, you can't say Manchester City, and you certainly can't say that S word, soccer. Although Manchester United, I feel sad for them. But I'm a Tottenham fan, so I feel worse for us. But then you can have PII, restrict the amount of information that can go out. And there's all kinds of categories, and you should be preventing this. And then there's contextual grounding. And contextual grounding basically tells the system, okay, you've come up with an answer, but does that answer actually make any sense? You're asking the system to self-reflect on what it did. Could it really have come up with that answer? It's a way to tell the system, essentially think about hallucinations. Now, on the other hand, and this is a good thing, and you should do it, but on the other hand, it is sort of like asking the fox, hey, did you go in the hen house? And it's like, oh, no, I'm fine. Don't worry about these invented logs. Don't worry about this insider trading. It's all good. So take it with some skepticism. And then we get to the shared responsibility model that we've been saying forever, but you have to do all these things. Last year I gave a talk on S3 ransomware defense, and we're talking about object lock and least privilege and all kinds of stuff. And after the talk, people came up to me and said, but Brian, I've got my data in Amazon, so I'm all set, right? No. No, you haven't. There's more to do. And all of these things matter, and you have to take them very, very seriously. Because most agents are actually invoked by lambdas. And on a recent customer engagement, and I'm not going to say who, we had a team say, well, all my agentic lambdas, I'm just exposing them using Lambda URLs, unprotected for right now, just so we can do some development. You do know you've just opened your whole system up to call that anyone can call anything. So, and they said, yeah, we'll fix that before we go to production. anyone here ever shipped something into production that wasn't meant to? It's just a prototype. It's just a POC. No one will ever push it to production. Of course, we've all done that. And if you say you haven't done that, again, with great respect, you're lying. And I can't believe I have to still say this in 2025, but oh my God, CloudWatch and CloudTrail, you have to be doing this, okay? So the call to action today is, I'm not sure if these slides are going to be available, but if you send me a LinkedIn message, I'll send you the slides. I'm Brian Tarbox. And my LinkedIn profile from a couple years ago, there's some booth at reInvent where they would make you into a superhero, and so I couldn't resist that. So it's Brian Tarbox with a picture with a cape and so on. And I'll send you the slides. Another thing I want you to think about is who you're hiring, because right now, agentic developers are sort of the hot area, and people are trying to find those invisible agentic developers. And as with all hiring, they're like, yes, I want someone with 3 years of agentic development. It's like, awesome, good luck to you. But I want to say, instead, hire a traditional developer. Hire a developer who's done microservices, who has done distributed systems. Hire a developer who has gone into production with anything. Until you've gotten that 2 in the morning pager duty, it's not visceral how important all these security matters are. So think about who you want to hire, because someone who's you can learn about agents, but sort of the overall view of, oh my God, I have to care about all these things, that's new. Always use guardrails. I think that just should be a given. And then go back and reread the shared responsibility model, because that's still really, and I should have come up with a better word than bedrock, but go read, the shared security model is the bedrock of everything we do. There's also, I want to point you out to the OWASP threat and mitigation website. And OWASP is Open World Application Security, and I never remember what the P stands for, Principal, People, Production. But it's a great summary of all the types of threats that you can have in the system. And that's it. But I think we have a minute or two for questions, if anyone had a question. Thanks very much.